Hello, Vladimir. How are you? I'm going to wait for a while, a minute or so, and I will start slowly. I believe somebody will connect to the live stream. If not, there will be a recording available on YouTube and as well on LinkedIn, so no issues for watching it later. Okay, I think we can start. There is no issue with a lack of attendees. I think everything is okay. So here is the KiCAD. I have prepared some stages as a demo to show how KiCAD can be powerful. Oh, this is what I want. Yes, can be powerful in like regular repetitive tasks. Let's say we want to change multiple symbols in schematics. Of course, you can change one symbol at a time, but it's not very effective. And yeah, here is a property of the symbol, and you can change this symbol in the contextual menu, but only you can choose the particular designator or components with the given value or symbols matching library identifier, but you want to change a group of symbols. So this is something you need to do this way. You need to mark all the symbols you want to change, then right click and change symbols. It's here in the contextual menu, not in any windows connected with properties. And now here is the checked first option, change selected symbols, and all symbols will be changed. And now you just navigate to your library. I can choose, for instance, something like this and change it. Be aware to check the value as well if you change the value of the capacitor or of the symbol. Otherwise, the value will stay valid for the old symbol. It means invalid. So now I changed all symbols at once. Just a few cosmetics and it's done. I only check the comments because I'm kind of lost in the comments on the live stream. Hello guys, hello Alex, Maria, hello, good afternoon, how are you? I hope everything goes well today. So I will continue with the stage 4, for instance. No, stage 4. Oh yeah, stage 4. Repeat the last item. This is, I think, quite a well-known feature, but probably not everyone uses it. So, for instance, you want to create something repetitive, and a short demo. I just draw a line, and then you call the command repeat the last action, and you repeat the action step by step after each click of the key or press of the key. And here is settings for it, because you can not only repeat in a vertical way but as well in the horizontal way. I need to take a look where to find, not in grids, editing options, here, repeated items. And you can see horizontal page is now set to 0. It means that the repetition will be in vertical way, but not any shift to in the horizontal way. And vertical page is 54 millimeter. It means it's 100 mil, which is quite standard grid in KiCAD for symbols, for drawing lines, because it's perfectly readable, and the 100 mil is like natural distance for the paints, for the lines. It's pleasant to see and to read it. And here, label increment, because you can not only repeat the drawing lines, but as well labels, and the labels will change the value for you automatically according the settings in the as I show you here, label increment. If I set any other number, naturally it will change the number according to the setup. Pin helpers in new KiCAD 8. I think it's quite interesting feature, but I didn't use it at all. Just once or twice if I observed what's new in KiCAD 8. The thing is that you need to click on the pin select. The symbol is unchecked. So in the same window setup, there is a selection section, and you need to uncheck the clicking on pin. On pin select, the symbol is unchecked, because otherwise you cannot access the symbol pins. And it works like this. You check, I think, how it works this way. No. Oh, look, I forgot how this feature works, because I don't use it. So let's find, and I will learn a new thing. Pin helpers. How pin helpers work? It was here. Here I need to. Yes, I need to select only the pads, not the entire symbol. Yeah, I was wrong. So you need to select the pins, the connectors, and then pin helpers, and you can draw a wire, in interesting ways. You can continue. No, you can't continue. Now, can I? No. And here, pin helpers active again. Net labels. So yeah, but there is something to check, to set the label, because I don't want some generic label. I want my labels. Oh, probably not possible. See, it's not so clever, or I am not so clever. I don't use it. I think the repeat last action is much more flexible, because you know what you want to do, and then you are, I think, more flexible and more fast, because I don't know. For instance, the labels. Yeah, there are labels pin 1 to pin 10, but you need to manually change all the values. So no, not so fine. Hello, Said. How are you? I hope you are doing fine today. Stage 5. Assign net class to labels. Yeah, here is the thing, that to be able to assign any net class to net, the net must be labeled. This is the first thing. And the second thing, the net class must be created in advance in PCB editor. So you go to the PCB editor, File, Board Setup, and here are net classes. Yeah, here is some generic net class I created before. For instance, single-ended 50 ohms. Yeah, doesn't matter the clearance, track width, keep it as is. What's important is the name, like the pre-selector to be selectable in the schematics. So save it. You can even close the PCB editor window. And now, when you select the label, hit the E key for properties, and then there is a net class. And you can set the default, which is the default net class, like nothing special, like normal net, normal track, net A, previously set, and recently created single-ended 50 ohms. So this is something you may know from the Altium Designer. They use like the symbol with two waves, I think, like the designator for the differential pair when you draw USB or HDMI or Ethernet. So some nets with the different repairs. So KiCAD is not so clever, but you can modify the net class descriptor as well. I use it this feature all the time because otherwise the net class descriptor is too big, the font is too big, and it's of the same size as the label, and it can make the readability difficult, or I don't like it. So properties of the net class field, net class descriptor, and usually I set the half size, and instead of dividing the 1.27 in half, it means 0.635, yes, you just hit /2 and see the KiCAD do the math for you, or any, you can choose any other denominator, but be careful when you leave the window, the equation, the formula will be lost and only the value will stay. So now I set half of the default value. Font can be the same because yes, I'm not fan of too much changing, because otherwise, for instance, when you send the project to your customer or to other people, the portability can be lower, because when you choose your favorite Super Trooper font and it's not available on the Linux machine or Mac OS machine, then the default font will be used anyway. So yeah, I always keep the default font. So this is the setup. I keep the Italica, and I place the descriptor usually above the net in the vicinity of the label. And my habit is to keep the labels above the wire, not like behind. So just by pressing X, it means X is the horizontal mirror. I place the label above the net, and now I need to rearrange the net class descriptor, but it's not a big deal. The plus is that when you copy the label for another place for your schematics like this, you can use your labels to draw wires or lines. The plus is that the net class stays selected, so it saves your time. This way you just need to change the label and it's done. As you saw, I mispress or wrongly press the R button. It's rotation. You can rotate not only symbols but as well the labels. Plus, when I talked about the horizontal mirror, there is a vertical mirror as well. It's naturally Y, and then you can easily mirror vertically not only the symbol but the labels as well. And it's practical in a way or in occasions when you need to mirror the connector. For instance, you are designing the schematics for the carrier board, and then you design schematics for the board to be plugged from above or from bottom. And now you need to be careful with the orientation of the connector. When you use, for instance, pin headers, then on the carrier board the pin 1 is on the left, but on the carrier board the connector must be from the bottom side, and usually the pin number 1 is on the right. So you need to mirror the connector. And to avoid any mistake, I recommend to just copy the entire connector with labels from the carrier board, place it to the schematics of the blackboard or from on the extension board, and then simply to mirror the connector. It's the only way how to not mix the signals and how to keep everything in order, because otherwise you do it manually. There is a big area for mistakes, and you don't want to make stupid mistakes. You want to make clever, smart, sophisticated mistakes, not stupid mistakes. So use smart tools. Mirroring is not so smart, but the technique is smart, I believe. So it was stage 5. Stage 6 is differential path display on PCB. I'll go there later. Block swapping. Interestingly or surprisingly, I was quite slow with this feature, and every time I need to change, for instance, logical gates or parts of the components like multi-part transistors or resistor arrays, or you name it, operation amplifiers, I always place the new symbol for instance all the like instances of the new symbol, and then I manually pick the, for instance, B gate and place the B gate on the place where I want to be placed. But after, I believe, and I have to admit, after a few years, I found that in the property window there is a unit section where you can easily change the block. So it opened my eyes and almost blown my mind, because before I had spent literally not minutes but tens of seconds, and such big changes created space for mistakes as well. And I want to minimize space for mistakes by using good techniques and strategy. Stage 8, pack and move. This is for transforming between schematics and PCB layout. It's about you select the group of components. For instance, you want to place the LDO with the decoupling capacitors, and you need to start with the decoupling capacitors because the decoupling capacitors for LDO is the most important thing. Here is the synthetic example, but it's valid. So you select the symbol of the IC, and for capacitors, then you go to the PCB editor, and I need to select it again with the open PCB editor, go to PCB editor, and now all the symbols, or in this window in the PCB editor, those are the footprints. By pressing P on the keyboard, like pack, you just pack them together and grab them on the window, on the cursor, and take them everywhere, anywhere you want. So it means that you simplify the block to a bunch of, to the group of the component which are needed to be placed the first, or at the same time, and then you place there somewhere, and you can continue with, for instance, this resistors. So you want to place half of them now, P, and those resistors are grabbed, packed, and you can place anywhere you want. You can even create a mark, like place them together as close as possible to the IC. And this is like work, preparation work, or the preparation for the PCB layout. I say that the proper PCB layout starts with the proper PCB, the proper component positioning or placement, and this steps help you to place the components correctly. And I think for simple PCBs, like, I don't know, I don't want to be too general, but let's say under 200 components, under or up to 4 layers, you need to spend half of the time placing components, because it saves you a lot of time when routing the tracks then, because correctly placed components is a must for the correctly layouted PCB or routed. So stage 9, filters. Yeah, this is the PCB editor. This is something. Yeah, I can show you. There are no any comment, any question. So I will switch to the PCB editor, and the task is I immediately forget. Filter selected items. Yes. For instance, there is for instance here, there is a place when there are textual objects, the footprint, and the tracks. So, for instance, you can imagine that there are much more tracks, and you need to choose, and much more components, much more footprints, and you need to select only footprints. So yeah, definitely, obviously, you can click each segment of the track and then you are done. But much quicker way is to select the entire area, right click in the PCB editor, then the first option is select, go to filter selected items, and then uncheck everything, because you need to select only tracks now. So with unchecked all options, just check the include tracks, and now only tracks are selected. And as you can see, there is a glitch or bug in probably maybe not a bug. Let's find out the cause if it's possible. So again, filter selected items. I chose the tracks, and the meanders, the length tuned part of the track was not selected. So what's wrong with it? Footprints, no. Vias, no. Text items, no. Drawings. I don't know if the meander acts as a drawing, but let's try. No. So again, filter selected items, not the drawings. Board outline layer, not at all. It's the edge cuts layer, and it's nonsense. Include zones. The meanders can act as zones. I don't think so, but let's try it. No. So in this way, in this case, you need to manually, when holding the control or command, the shift key, you need to add the meanders to your selection. So as you can see, KiCAD can save you a lot of time, but as a tax, sometimes it makes you to spend more time than necessary. But yeah, if you know how to fix it, or how to solve it, you are happy. Stage number 7, yeah, I was there. Stage 11, import DXF graphics. Yeah, we can try. For instance, mechanical engineer sent you the graphics in the EXF format or in step format, and then you export it to the EXF, but because KiCAD can't import the step, but it can import the EXF. And the way how to use it is the following. Let's go back for a second. Why you need to import the EXF graphics? For instance, the PCB shape is too complex. Then it's comfortable to draw in KiCAD. So somebody or you draw it in other tool, and then you export the EXF to be imported here in KiCAD to save your time, because KiCAD is not great for graphics. Import is the correct part, correct place, graphics. And here is the window for the importing. Navigate to the file. I think, yeah, here is the demo shape, PCB shape DXF I created before. And you need to know the scale of the graphics. Let's say it's a 1:1. The line width, I think for the edge cut is 0.15 or 0.12. I should need to check, but I think 0.15 is a good value. Millimeters is probably fine. And the layer, when you want to import the PCB shape, is the edge cuts layer. Group imported items, it's just an option that all, for instance, you have a shape with the rounded corners and some complex edges. So each segment of the edge is one line, and when you keep the selection group imported items, the entire shape will be grouped, and then you can ungroup it by one click in the menu. So I usually keep the option checked, and if I want something change in the shape or modify it, I ungroup that and change it in the KiCAD. So here is the shape. You can rotate it as you want and place it there, and see it acts as a group. And the ungrouping is possible in the menu grouping, ungroup items. And now you can access each segment of the shape, or if you want, you can group the shape again and move it as the single object. So no questions, no comments. Please let me check for a while the LinkedIn account. Not here, definitely not here. Here. Probably not. Never mind. I will continue with the stages. So stage 12, move absolute in the PCB editor, move relative in the PCB editor. I think those two functions are the most useful, if not definitely my favorite. For instance, and I will show you a trick. Sometimes you need to reference a particular spot on the PCB, And the KiCAD is not great for mechanical drawings, and it lacks features like anchoring to some edges or points. It's not great, but I will show you a trick. If you want to reference, for instance, this spot, I recommend to place via there in the most fine grid. It means that when you miss the correct point, you are wrong by 1 mil, which is well under tolerance of the PCB manufacturing process. So place the via there, and then, for instance, you want to place this resistor. Imagine it's a resistor, it's any component you want, but it's a strict requirement. Then this resistor must be placed exactly 10 millimeters in the vertical dimension, and 5 millimeters in the horizontal dimension. So then prepare the rough position here and place or choose the positioning tools, move relative to or position relative to, and then I say 5 millimeters horizontally and 10 millimeters vertically. The 0 point in KiCAD is on the left top corner, so it means 10 is downwards and 5 is to the right. So 5, 10, and then you need to choose the item. If there is a good point, because KiCAD can snap to graphics, but otherwise, for instance, in the middle of this line, middle is as well good, but yeah, imagine any non-specific place like like endpoints or midpoints. It's hard to anchor. So then there is a via as an object, and by pressing OK, the component is placed. The center of the resistor is in the middle of the component of the footprint, and we can check. Here is the relative scale. So when in the center of the via, I can zero the scale by pressing space, and the center of the resistor footprint is 5, and then you can see the grid is so fine that even slightly move of the cursor goes around the 5 and 10, but it's a correct position. So this is move relative to with a short small trick, and then the second one, move absolute. For instance, you know that the previously 10 and 5 position was good, but now it must be 5 and 6. And the easiest thing is to move 1 millimeter to the right. So 1 millimeter X. There is no reference point because you move one object absolutely. Pick, and you are on 10 and 6. So let's get back to the schematic. Hello, Chris. Hello, Chris. If anyone who is watching now have any wish to for a KiCAD to me, like I will show you how to do anything. If you have any issues with your process of creating schematics or PCB layout, feel free to ask, and I will do my best to explain how to do it with online interactive demo. So I will check the comments on LinkedIn. There are some notifications, but yeah, the last one is from Chris. Thank you, thank you. And nothing more. So let's get back to the KiCAD. Yeah, no comment, no questions, no wishes. Never mind. So we are in the PCB editor. What else? The create from selection. Create from selection is a great thing, for instance, for stitching vias. Let's say that I will use this PCB shape because I like it. For instance, there is a place when there is, for instance, antenna. We can place antenna there even. Let's do that. Antenna from my library. For instance, here is the library antenna. Please don't judge me by placing it. I just want to show you how to use the create from selection tool. And let's say that the entire part of the PCB will be covered by the copper plane, grounded, connected to ground. And you need to place the stitching vias there, and the entire area must be filled with the stitching vias, and you want to deliver the nice looking job, so you need to place the vias in the grid, not zigzag, but in the grid, because it's pleasant to look at a well driven and well drawn and well designed PCB. So place the first via anywhere, like here. It doesn't matter. Now select the via, then go to the contextual menu by right click of your mouse or trackpad, and go to the create from selection part, and there is create array or command or control T, and this command is very clever and I like it. Here is the grid array size. Let's say there can be 15 horizontally and 10 vertically. It's a rough numbers, and then I will show you in a minute. I'm going to show you how to make some iterations to get the most perfect result. The horizontal spacing can be even 2.55, 54. It's okay. So let's try it. Oh, it's not bad. It's not bad. We need one row less and two columns less. So let's undo the action, and again create array. So I set 2 column less and one row less. In one click, you placed stitching vias in the entire area. Let's say you want to move it close to the antenna, so select the entire array, and by pressing the cursor keys, you can move slowly in a grid increment, move to the close to the antenna. It's a synthetic example, and I need to say that you can use it with any other object or multiple objects on the PCB. For instance, I copy 6 vias from here, select them, create from selection, create array. The horizontal spacing must be much bigger because the group is bigger. And now I copied the 6 vias in an array. or it can be resistors, or any footprints, or any objects, mounting holes, anything, you name it. It saves you a lot of time. And for instance, you want to just like the border. Why not? Just delete the inside, the inner part, and you are done. Yeah, you need to play with you can play with the KiCAD, and it's fun. So yes, Matteo. Hello, Matteo. How are you? No problem. I am happy I can share my 5 cents of KiCAD knowledge. Good afternoon or good morning, Luan. How are you? So I think we can get back to the schematics to see what else we can do or we can show. We went through the entire prepared stages, or at least through the interesting parts. No problem, Matteo. Thank you. I'm happy that you like it. Feel free to ask any question if you want. I will interactively show you how to do it in KiCAD. I believe I will repeat this session soon because today there is not many questions, many comments, but I think it can be useful for especially beginners and juniors using KiCAD, and for instance who moved from other CAD tools like Eagle, Altium Designer, or similar. So, okay. The recording will be available on LinkedIn. I will make some short sections from the recording of the webinar or the live stream for the YouTube and as well for the LinkedIn. So the most interesting parts will be copied and shared separately. Thank you, Maria. I'll be waiting for the next session as well. This first session was kind of a rehearsal, but I think it can go well. Definitely, my takeover from this is that I need to organize the session earlier in the week, because Thursdays are the toughest days of the week, and probably at some earliest time I need to probably issue some poll when the audience can choose the most appropriate time for such a session. I think 45 or 50 minutes is fine for today, so I will conclude the session. Thank you everyone for attending the live stream. It was great fun. I learned a few things about the entire live stream and LinkedIn thing, and see you in the next time. Bye.